Welcome to Math with EJD. I've been taking you through a series of classes on matrices, and today we turn our focus on the rule of Sarrus. That is the Sarrus rule for finding determinants. Interestingly, this method is only restricted to finding determinants of 3 by 3 matrices. So, and it's a very simple thing. It involves summing the products of diagonals from the upper left to the lower right and subtracting the products of diagonals from the lower left to the upper right. Now, this may look abstract right now, but when we get to look at it in depth, you will understand. Of course, before now, you understand looking for determinants of a 3 by 3 matrix. It involves, taking the one element on the first row and crossing it out, crossing the row and column out and finding determinant of a 2 by 3 matrix. And you do that like that. But I mean, the Sarrus will present a more efficient method, a simpler method, a simpler technique to handle 3 by 3 matrices without going through all of that trouble. Okay. All right. So the fundamental demonstration, this fundamental technique is what you have here, the first demonstration. And from the definition we have down there, right? This is how it goes. You have, okay, you multiply, you take this cross this way, one. So that's A11, A1, A22, A33 multiply together. This is what you have here. And it's positive, as you can see. Then the other one is you take this and then it comes into this corner. So you have A12, A23, A31, and that's what you have out here. Then you also have, so you started from A11, then A12. The next is A13. But for A13 now, this is how you go. You go A13, A21, A32. So A13, A21, A32. That's what you have right here. And having taken care of that, so for the positive ones, right, you started from the top. But for the negative ones, you start from the base. And the first way is you go A31, A32, A13, and that's why you have this. Then the next one would be A32, A23, A11. That's why you have this. A32, A23, A11. That's this. And lastly, you have this one. That's A33, A21, A12. That's why you have this. So at the end of the day, you sum up all this and you subtract all this from that, and then you get your determinant. Isn't it really cool? But even this, with all the corners, it can be it may be still confusing for some people. That's why we have demonstration too, which I think drives the point home even better. So what happens there is this. Okay, let me get rid of this line so you can see how it's all drawn. Okay. Now, so for demonstration, so of course you already understood from the other one that you have to do A11. Oh, sorry. I'm still using the eraser, so let me get rid of it. Okay. So you already understood that what you did in the other place was to multiply A11, A12, A13, and then A12, A23, A31, A12, A23, A31, then plus A3, A13, A21, A32. That is A13, A21, A32. That was it. So that is basically the arrangement you still have here, except that they do not follow the same order, but it's the same thing at the end of the day. A11, A22, A23, that's normal. Then this is the next one is A12, A23, A the next one is A12, A23, A31. So that's what you have here. Though the other is not followed because of this new method we have now. So that's for the positives, right? And for the negatives, what did we do? We did A31, A32, A13, and this is what you have right here. And then we had A32, A23, A11. That is A11. You see A11, A32, A23. You still have that. And this last one is A33, A21, A33, A21, A12. That's what you have here. So A33, A21, then A12. So, but then because all of that can be confusing, we have even a better presentation. All you just need to do in this case is to write the first two rows, write the normal matrix, like this. I mean, the 3 by 3. Then you now continue by writing the first two rows afterwards. So this is the normal matrix. Then you now have the first two rows under it. And with this now, it becomes pretty easy to even compute. So what you just have to do here is, of course, if you do this, this is only one, this is only two. But the first place where you have three, go. That's 1, 2, 3. And oh, sorry, no, 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 no. So I mean, coming down now from the definition, right? You're coming from the top to the bottom first for the positives. So you have 1, 2, 3, you have 1, 2, 3, and you have 1, 2, 3. And that's why you have A11, A22, A33. This what you have here. Then A21, A21, A32, A13. That's what you have here. Then A31, A12, A23. That's what you have here. So all that for the positives. And then for the negatives, let me change the marker. So for the negatives, you have let me go green. Maybe not green. Say purple. No, not purple this time. Black. Black is good. So now you have for the negatives 1, 2, and 3. And that's for the negatives. And that's A31, A32, A13. That's what you have here. A11, A32, A23. That's what you have here. A21, A12, A33. That's what you have here. So sum up and subtract, and you get your result. And that is the Sarrus rule. So let's take examples straight to the point. First example, this is what you have. Because the second demonstration is so easy, I think it's better to stick to that so that you don't get confused when you're drawing the lines. Normally, if you want to draw the lines, you do, oh, okay, this is black on black. Let me do something, let's say light blue. So 159, that's what you should have. Then the next thing is 267. That is it, 267. And then the last one is 348. And that's what you have, a 348. So that still works. Then, of course, the negatives will be 753. That's what you have here. Then you have 861. That's what you have here. And then you have 942. That's what you have here. But then, because the lines may be confusing, what I just do is I just do the normal, okay, maybe I should get rid of the lines again so you can see clearly. So so you just write 1, 2, 3, write the normal matrix up to this point, back here, write everything normally, then you write the first two rows in addition. So once that is done, then all you just need to do is to, take 159, 483, 726. That's for the positives. And for the negatives, we can have for the negatives, let's go black for the negatives. So you have 1, 2, and 3. That's for the negatives. So that's why you have 1 times 5 times 9, 1 times 5 times 9, like that. 1 times 5 times 9, 4 times 8 times 3, 7 times 2 times 6. Then for the negatives, you have 7 times 5 times 3, minus 1 times 8 times 6, minus 4 times 2 times 9. So with that settled, you just need to tidy things up. 1 times 5 times 9 is 45. 4 times 8 is 32 times 3, that's 96. 7 times 2 is 14. 14 times 6 is 84. Yes, 84, like that. So that's for the positive. So they're all positive, so that's why you can just add them up this way. And all these other ones are negative. That's why you have minus outside and you can put all of them inside, because if you expand this, you still have minus this, minus this, minus this. So it's better to do it this way. 7 times 5 times 3. 7 times 5 is 35. 35 times 3 is 105. 1 times 8 is 8 times 6, 48. Then 4 times 2 is 8 times 9, 72. Then by the time you add all of that up, then you add all this up, you have 225. You add this up, you have 225. And the determinant of this matrix is 0. Now, for this kind of matrix that has a determinant of 0, it means that it is singular matrix. It is singular. So because it is singular, what happens? It has no determinant. It has no determinant. It has no determinant. No determinant. No determinant. That's what we have seen now. And because it has no determinant, it will also be non-invertible, meaning no inverse too. You cannot find the inverse of this matrix. No inverse. In addition, it means that if you take it to reduced row echelon form, it means that the rank of this matrix, will be less than the than than the full form. The rank of this matrix will be less than the order of the matrix. It's a 3 by 3 matrix, so the rank will be like 2 or 1, most likely 2. So the rank is less than the order once the determinant is 0. So it is a matrix not having full rank. You can check other previous videos to get these concepts more clearly. Where I was talking about singular matrix, the rank of a matrix, and things like that. Okay. So that's easy. We take one more example and see how that goes. All right. So let's go to the next one. Example 2. Example 2. See what you have. So this matrix is what you have now. 2, 1, 0, minus 1, 3, minus 2, 4, 0, minus 5. Again, if you follow the normal rule, what do you get? You have follow the normal rule. You have 2, 3, minus 5. That's what you have here. Then 1 minus 2, 4. 1, 1 minus 2, 4. That's it here. Then lastly, 0 minus 1 minus 5. Oh, sorry. 0 minus 1, 0. You can see that can be pretty confusing, right? So that's why this other method is better. Then, so that's for the positives. For the negatives, you have 4, 3, 0, and that's what you have right here. Then you have 0 minus 2, 2, 0 minus 2, 2. That's it here. Then you have minus 5 minus 1, 1, minus 5 minus 1, 1. So that still follows, right? But because drawing these lines, as you can see, it's even me, I get to stumble over it sometimes. So it's better to do something you're sure of. And I mean, this is pretty easy. Just write the matrix minus 2, 1, 0, minus 1, 3, minus 2, 4, 0, minus 5. And then just write the first two rows, 2, 1, 0, minus 1, 3, 2, this. And then with that, it's pretty easy. Just start from the top here, go 3, go 3, go 3. So, and that's for the positives. For the negatives, you just, for the negatives, you can now have this. Just go 1, 2, and 3. And that's for the negatives. So you have 2 times 3 times minus 5, which is 2 times 3 is 6. 6 times minus 5, that's minus 30. Then the next one is 1 minus 1 times 0 times 0, minus 1 times 0 times 0. That's this 0 here. Then 4 times 1, 4 times 1 times minus 2. This you have 4 times 1 is 4 times minus 2. That's minus 8. Then minus then 4 times 3 times 0, 0. 2 times 0 times minus 2, 0. Minus 1 times 1, that's minus 1 times minus 5, that's plus 5. So by the time I'm putting all this together because they are all negative. So you can have it this way. Then all these are positive, so you can put them together. So minus 30 plus 0 is minus 30 minus 8, that's minus 38. Then this is plus 5 in the bracket. The minus is outside, so you have minus 5. So minus 38 minus 5. So the determinant of this matrix is minus 43. So you see the rule of Sarrus, or the Sarrus rule, makes finding determinants of a 3 by 3 matrix pretty easy, So with this, I can say I've come to the end of this, but you can try your hands on these matrices. Find the determinant of the following matrices using the rule of Sarrus. The first one is minus 2, 0, 1, 3 minus 1, 4, 5, 2 minus 3. And then the second one is 0 minus 1, 2, 3, 4, minus 5, minus 6, 7, 8. So thanks for listening. I am sure you are learning a lot on this channel. So keep coming back. There's still so much to learn. Bye.